Hi science students, welcome back. Today we're going to focus on ionic bonding. We're going to talk about what forces hold ions together and how their structure can change as we add more ions into the picture. So let's start with how ions actually bond together and create ionic bonds. Let's first look at these two anions that we see, these two negatively charged ions. So as I move them together, we can see that they repel and push away from each other, just like magnets. So opposites are going to attract and alike ions are going to repel. So when we look at our positively and negatively charged ions together, we should expect that they're going to attract, and as I move one, the other draws towards it, and as long as they're close enough, they'll stick together. So oppositely charged ions are going to attract, like we see in the image. When they're close enough, they'll stick together. And alike charges are going to push away or repel from each other. So we know opposite charges attract and alike charges repel. So in order to build an ionic bond or an ionic compound that stays together and sticks together, I need two opposite charges. I need a positive cation and I need a negative anion. And as a rule of thumb, I should expect that I can find those cations and anions in certain places on the periodic table. So let's start with those positive ions. Positive ions are going to form from an atom that has a tendency to lose its electrons. Typically, this is going to be an atom that has a small number of valence electrons. We know that in order for an atom to be happy, its valence has to be full. And if I only have a couple electrons moving around in my valence, I want to get rid of them. I want some other atom to take them so that my valence is full and I'm a happy atom. Since a lot of metals are on the left-hand side of the periodic table, we know that those are going to have lower numbers of valence electrons, and those metals are going to more easily lose those electrons to other atoms. When that happens, they create a positive ion, a cation. So positive ions are going to almost always be metals, and they're going to be on the left-hand side of the periodic table, this orange space that we see right now. And the opposite is true of negative ions, of anions. So anions are going to be formed from an atom that has a tendency to gain electrons or steal them from other atoms. Nonmetals are going to form ions by gaining electrons. And so those negative anions are going to typically be nonmetals. Atoms on the right-hand side of the periodic table, except for noble gases, will typically tend to form anions or negative ions. We know these noble gases are not included because they already have a full valence shell and they don't need to add or bond with any other atom in order to have that full valence. But all of our other nonmetals typically do need to bond, and they create those negative ions. So far, we've learned that metals form positive ions and nonmetals form negative ions. We know those positive ions would be called cations and those negative ions would be called anions. Therefore, metals and nonmetals are going to bond together and form ionic bonds really well with one another. So let's take a closer look at this. Let's use sodium and chlorine. We see sodium here on the left side of the table as a metal, and we see chlorine over here on the right-hand side of the table as a nonmetal. Here they are in little atomic versions, and so chlorine atoms have a strong attraction for electrons. Chlorine is going to want to gain electrons to fill its shell, and sodium is the opposite. Sodium is going to want to lose electrons to have a full shell. So under certain circumstances, the chlorine atom will be able to take one electron from sodium, and sodium will lose that electron. So an electron will be ripped away from sodium and turn into a positively charged sodium cation. Chlorine will gain that electron and become a negatively charged anion, and we'll call that a chloride. So we'll drop the I and E from chlorine and we'll add an IDE for chloride because this has begun to create an ionic compound. And we'll talk about naming in the future, but for now we know that one electron is being stolen from the sodium and given to the chlorine. And we can see that happen. Chlorine becomes negatively charged. It has that extra electron in its valence now. And sodium becomes positively charged because it's lost that electron. Because they have those positive and negative charges, that's what makes them ions, and that's also what attracts them to each other. Because the sodium is positive and the chlorine is negative, they're going to be held together by the attraction between their two opposite charges. And this is what's called an ionic bond. Ionic bonds are going to come together and hold together because of those positive and negative charges of the two different ions. So let's look at another example of this that closely resembles what it would really look like in the real world for them to bond together. We see chlorine on the left and sodium on the right. Chlorine is typically found in nature in pairs as a gas, and sodium is typically found individually, but if it's a solid, it's not going to bond with chlorine. And so what we have to do is we have to heat it up, and it vaporizes, and it separates the sodium atoms from each other. And those vaporized sodium atoms can then bond with chlorine. So each chlorine atom, that Cl2 that you see, those two little blue atoms, are going to need one sodium atom to react with. And we see two of those off to the sides. So as they pull towards each other, that electron is exchanged, and then they create that ionic bond with each other. The sodium is positive, the chlorine is negative, and they create that sodium chloride molecule with each other. But if we were to continue to watch, what we should expect to happen is that they will not stay separate molecules like that. They want to be surrounded by oppositely charged ions. And so instead, what we'll see happen is that the positive ion over here will attract to this negative ion over here. And this positive ion over here will attract to this one. And it creates this little crystal. So the positive ions are going to attract with any negative ions around them, just as the negative ions will attract with any positive ions around them. And they'll continue to do this. There's no max number. They want to be surrounded by ions that are oppositely charged from them. So we can see that same thing happen in this scenario with many more of these sodium chloride ions. And what we'll see happen is an ionic crystal will form. They'll continue to kind of maneuver around until all positively charged and negatively charged ions that can attract to each other will. This is a 3D model of that same ionic crystal that's been combined, and we can see those sodium and chlorine ions have bonded, and they're surrounded by oppositely charged ions to create that ionic bond in that ionic crystal. That's everything I have for you today. That was a really quick crash course in ionic bonding. If you need to go back and replay parts of the video, please do so. If not, please have a really great day. Bye-bye.